Hey guys, so the problem we're going to be starting with today is as follows. It says, give the differential equation that has y squared equals c1 x cubed plus x as its general solution. So how we're going to approach this problem is by, whenever you start with the left part, which we're going to be starting first, we're going to be taking the derivative, of course, with respects to y. And whenever you do that, of course, we get 2y times y prime. If you guys remember from cal 1 and pre-cal, anytime you take the derivative with respects to y, always write y prime. Then whenever we work with the right, it's going to be with respects to x. And the c1, all that is a constant, so you don't have to really worry about it. So a constant, just a constant, so it stays there. And the derivative of x cubed is 3x squared plus, and then it's 1. Okay, whenever we get to this point right here, you want to solve for c1. So just always keep that in mind. Okay, I took the derivative with respects to w on the left and respects to x on the right, and now we solve for c1. And I'm going to start by moving that 1 over, so subtracting everything by 1. So we get 2y, I'm sorry, times y prime minus 1 equals c1 3x squared. And of course, to continue, we want to solve for that c1, so we'll divide everything by 3x squared. So then we get 2y times y prime minus 1, everything divided by 3x squared equals c1. Okay, perfect. That's what we wanted, right? So we're just going to bubble this real quick because we're going to be using this. Whenever you get to this point and you have already solved for c1, what you want to go ahead and do is plug it in to the original equation that was given to you, which is that one right here. Okay, so everything that c1 is going to be there, and I always recommend writing c1 with parentheses on the side. So if we plug c1 back into there, we're going to get y squared equals, and of course parentheses, and everything what c1 is. So it's 2y times y prime minus 1 equals 3x squared. We close the parentheses, and then we just continue pretty much what's left over, which is x cubed plus x. Okay, so whenever we get to this point, we want to simplify already, and from here on out, it's simple algebra. But it always, you always got to be real careful. So we know that we can simplify this x squared with that x cubed up there. We can simplify that, bring it down, so then we get 2y times, and then we only have 1x up there, plus x. Okay, and so once we simplify as much as possible, once c1 has been plugged into the original equation, what we're going to do now is, we're almost there, is get it into y prime form. Now we solve for y prime. Like the answers that were provided to us, that's the form we wanted in. So, from this point on, just subtract everything by x, since we want to be solving for that y prime that's in there. So now we get y squared minus x equal, and I would still keep everything in parentheses just because you don't want to make any simple mistakes. Okay, and at this point we can divide everything by x. Okay, so we're going to go ahead and do that by that x right there. So we divide everything by x, we're going to get y squared minus x divided by x equals, then you could drop the parentheses at this point. It's 2y times y prime minus 1, everything divided by 3. Okay, and we still can't get to y prime yet, so we got to multiply everything by 3, since that 3 is blocking us from getting to that y prime. So we multiply everything by 3, so we get 3 multiplied by everything what's on the top, so you get y squared minus x, all of that divided by x, equals to y times y prime minus 1. Okay, we're almost there. We're almost there. So now we add everything by 1. Okay, so then we get 3y squared minus x, everything divided by that x. And so we wanted to add 1, so just add the 1 equals 2 prime. We're almost there. We're almost there. So now divide everything by 2y. So that we get 3 and then we said by 2y, so then we get x times 2y plus 1 over 2y equals y prime. Technically, you could stop here, but you want to be able to see that answer, the one that you have. So in order to combine these two fractions, we know that the only thing that's missing from the denominator right here is that x. So that means everybody from here gets multiplied by an x, okay? So we get 3y squared minus x divided by 2xy plus, and we said we were going to multiply this fraction by an x, so the top one gets 1 as well. So it's x over 2xy equals y prime. Okay, now we can combine these two denominators, and then of course we would add the top. And while we do that, we want to go ahead and distribute that 3 in there as well. So we'll get 3y squared minus 3x, and then we add the top part, which is plus x, and then we know that all of that is being divided by 2xy equals y prime. Okay, and then we just simplify the top. So then we get y prime equals, then we get 3y squared minus 2x divided by 2xy, and boom, that's our answer. This guy right here. And we box it, and that's exactly it. So we're gonna do a second one and a third one, and it's going to be the same process. You start by taking the derivative with respect to y on the left, with respect to x on the right. Once you have done that, solve for c1. Boop, so you have c1 there. And then you plug it in back to your original equation. Once you do that, you're going to simplify as much as you can, and that's whenever you have to start solving for y prime. And like I said, it's all algebra from here on out. And eventually, once you have combined any fractions like we had here, you'll get to your answer. Okay, guys, so right now we have the second question. And if you guys want to do the same steps that I did on the first question, you're more than, you can just go ahead and pause the video, try to do the same steps that I did, and let's see if you could get the answer, which I'm pretty sure you guys will. I know you guys will. So the question says the function y equals c over x minus 4 is the general solution of, and then we're giving our choices. Okay, so let's do the same thing we started last time. Okay, so we look at the function that was given to us, and we take the derivative with respect to y on the left, and which is just 1. But what we always said is, not only is it going to be 1, it's going to be times y prime always. And then the left, we take the derivative with respect to x, and if you guys know that shortcut, you know that it's going to be negative c over x squared, and that's it, plus 0. Okay, then you simplify it. It just looks like y prime equals negative c over x squared. And what we said last time was that at this point now, once we're done simplifying as much as we can, we want to solve for that c. We want to get c by itself. So let's multiply everything by a negative x squared. So then we get negative x squared times y prime equals c. And boom, that's exactly what we're looking for. And we know that the next step here is going to be to plug in what we found for c back into the original equation. So we're going to get y equals back to the original equation up there. And we want to put all of that in parentheses just so we won't get confused with anything. So we get all of c is negative x squared times y prime. And all of that is being divided by x minus 4. Okay, and we can still simplify this part right here, this fraction. We know that the top and the bottom have an x in common, so y equals negative x times y prime minus 4. And whenever we get to this step already, we're pretty much done simplifying as much as possible. All it is, like we've been doing earlier, is just algebra. So now we want to just solve for y prime, okay? And we notice that, okay. And whenever we look at our answers, we see that it could either be, we know it's not going to be a y double prime, since, we only have a y prime here. And so it's going to be pretty much, in a general solution form. Okay, so if you look at our answers, you can pretty much look at that there's going to be pretty much no fractions involved, and everything's going to equal to 0. So we can pretty much just add this whole part to the other side. So then we get y prime x plus the y that was on the other side equals negative 4. But we want everything equal to 0, so let's move that 4 over. And then we get y prime times x plus y plus 4 equals 0. And is this any of our answers? Yeah, it is. It was our answer D. So we knew it was in that form. There pretty much weren't going to be any fractions there. So much simpler one than the first. So what we're going to go ahead and do with this problem is we have two constants, this time constant 1 and constant 2. Not only are you going to take the derivative once, so of course we're going to do y prime equals, that becomes a 0, and we're left with the constant 2, 6x to the 5th, but you also have to take it twice now. So then we do y double prime equals c2, which is 30 x to the 4th, and you're going to save these, okay? I'm going to save these. You get y prime and y double prime, and what our problem says is, like one of them says, let's get number C. It's x times y double prime plus 5 y prime equals 0. So that means that you're pretty much going to have to be plugging y prime and y double prime into each one of these individually until you get your solution to be 0. So let's try D. X, which is x y double minus 5 y prime equals 0. So we know that it's x times y double. We know it's c2, 30 x to the 4th minus 5, and then y prime is c2, 6 x to the 5th. We distribute the 5 in there, and that x, so we get c2, 30 x to the 5th minus c2, 30 x to the 5th equals 0. And look at that. These two cancel each other out, and 0 equals 0. Yes, it does. So, that's our answer, which is D. So that's what you would have to do for, if you didn't know the answer, you would just pretty much have to pick and choose and to make sure you get a 0. Alright guys, I'll be posting these solutions up online. If you guys have any questions or concerns, just let me know, and I'll be doing this all the time. I'll be doing 1 problem, 2 problems, pretty much the same thing, and I'll always be adding a 3rd problem as a bonus that's pretty much the same but a little bit different, and it could be quite tricky. Okay, so I hope you guys enjoy. Give it a like, share if you guys found it useful. Good luck.